Ackermann steering, designed in the 1800s by Rudolf Ackermann and is still in use today. It allows the outer front wheel to turn in a wider circle than the inside wheel. The steering wheel is connected to the rack and pinion, which moves the wheels via the track rods. The track rod is connected to the wheel with the steering arm. A steering mechanism should be precise, provide feedback from the road, and should have a tendency to return to the straight ahead position after a turn. Caster is the angle between a line extending through the steering pivot axis and a vertical line through the center of the wheel. When the steering pivot axis meets the road in front of the wheel contact point, it will result in an inbuilt tendency to travel in a straight line. With a T-trolley, the wheels always follow the direction in which the trolley is pushed. Most cars have positive caster. When viewed from the front, the tilt of a wheel is called camber. If the wheels lean out at the top, it is called positive camber. With negative camber, the bottom of the tyre is further out than the top. This helps to improve cornering ability. Scrub axis is the distance between the steering axis road contact point and the center of the wheel. When both meet at the same axis, it is called zero scrub. When the steering axis point is towards the inside of the wheel, it is called positive scrub radius. Braking force on this wheel will tend to turn it outwards. When the steering axis point is towards the outside of the wheel, it is called negative scrub radius. Braking force on this wheel will tend to turn it in. Ideally, when a car is cruising on a straight road, the front wheels should be parallel. With toe in, the front of the wheels are set slightly towards each other. This is normally used on a back-wheel drive car. When the back wheels drive the car, the front wheels will tend to splay out or straighten as any slack in the steering system is taken up. With a front-wheel drive car, the wheels are set to toe out. When the engine drives the front wheels, it will tend to pull in and straighten the wheels. Correct wheel alignment ensures better fuel economy, tyres will last longer, and safer motoring. With a hydraulic power steering, the hydraulic pump is driven by the engine, and the power steering oil is directed to the actuator via the rotary control valve and hoses. When the steering is at rest, the fluid exerts an equal pressure on both sides of the piston. When the steering wheel is turned, a torsion bar connected to a rotary valve diverts more oil to one side of the piston, providing assistance in that direction. Early power steering systems were belt driven by the engine, with the pump speed proportional to engine speed. Often this results in the high pump speed when it is not required. It also reduces the power available for the driven wheels. With an electro-hydraulic system, an electrical motor is used to drive the hydraulic pump. When the pump is not required, the motor is switched off, saving power consumption. Another solution is a complete electric power assist system. Electric power steering (EPS) uses an electric motor to provide assistance at low speed when the steering wheel is turned. It provides variable assist depending on vehicle speed, max assistance when stationary, and no assist at high speed. Since it only takes power from the battery when required, it will help improve fuel economy. A rotation and torque sensor measure the rotation of the steering wheel and forward this data to the ECU. This information, together with road speed, determines the amount of assistance provided. On modern cars, the motor is usually connected directly to the steering column. This speed-sensitive electric system is also lighter and cheaper than the hydraulic equivalent. Oversteer occurs when the back of the car swings out when cornering and can result in loss of control. It is corrected by reducing the steering angle. Understeering occurs when the front of the car slips out or runs wide. A small amount of understeer is more desirable than oversteer. Coil springs store and absorb shock energy by compressing and extending. When the wheel is pushed upwards by the pump, the spring prevents the shock from reaching the chassis and maintains the tyre in contact with the road. A damper converts the oscillations of the spring to thermal energy. The damper is filled with oil. When the car hits a bump, the oil is forced through a small orifice, thus slowing down and damping the movement of the piston. The suspension consists of springs, linkages and dampers and connects the car with the road surface through the wheels and tyres. It provides comfort for the occupants and helps maintain the wheels in good contact with the road, providing traction, maintaining stability and reducing stopping distance. A twin-tube damper has an inner and outer tube. The piston moves in the inner tube and hydraulic fluid is displaced to the outer tube. The restricted flow through the orifice slows down and controls the movement of the piston. Compressed air or nitrogen allows for the additional volume taken by the piston rod as it enters the cylinder. A dead axle is not part of the drivetrain. The wheels are attached to it and it supports the weight of the vehicle. A live axle also drives the wheels and includes the differential. Leaf springs are made from layers of spring steel and are generally used on trucks. A panhard rod is allowed to pivot at both ends. One end is attached to the car structure and the other to the axle. As the axle moves up and down, the panhard rod prevents lateral movement. They are common on trucks. With an independent rear suspension, there is no axle between the wheels. The wheels can move independently of each other. Examples include trailing and semi-trailing arm. With a trailing arm, each rear wheel is supported by an arm hinged to the structure of the car. There is no change in camber as the wheel moves up and down. With semi-trailing arm, the mounting point of the car structure is offset at an angle. This allows the designer alter the alignment and camber as the wheel travels over bumps. An unsprung mass or unsprung weight is the mass of suspension components attached to the wheels. Ideally, the unsprung mass should be as small as possible compared to the sprung vehicle mass. A dead axle or rigid beam axle uses a single piece of metal sprung beneath the vehicle, which the wheels are attached to. It has high unsprung weight. Also, the up and down movement of one wheel will also affect the other side, reducing comfort for the occupants. However, they are strong and good load-bearing capacity, suitable for trucks. With an independent suspension, each wheel is connected by its own linkage and its movement does not affect the other wheel. An independent suspension has less unsprung weight and allows the wheels to move independently of each other. A double wishbone suspension has two wishbone-shaped links attached to the car at the wide end, and the narrow end is connected to swivel members which have the stub axle and wheel. The spring and damper are located between the lower member of the car structure. In most cars, the wishbones are not of equal length or parallel. This system is expensive to manufacture but gives good stability to the wheel. They are often used on racing cars. The wishbones can be designed to alter the camber of the wheel as the suspension is deflected. Negative camber provides better stability as the car corners. The McPherson strut has a telescopic strut anchored at the top by a flexible rubber mounting. The top mounting includes a bearing which allows the complete strut to swivel and steer the car. The transverse link is connected to the strut with ball joint. To absorb road shocks, a coil spring surrounds the strut, which also contains a damper. The McPherson strut is mechanically simple, takes up less place, allows more space for the engine and occupants. It also has low unsprung weight. They require considerable vertical height, and the body has to be strong where the strut is attached. A CV joint or constant velocity joint allows connection from the drive shaft to the wheel. It allows movement in all directions and is covered by a rubber boot to prevent ingress of dirt. When a car corners, the body tends to roll or sway. In this demo, we have omitted the springs and dampers for clarity. An anti-roll bar, sway bar or torsion bar connects left and right side suspension to each other. As the suspension is compressed on one side, it exerts a twisting force on the torsion bar, transferring some of the load to the other wheel, reducing body roll. Most cars have a front anti-roll bar, while sports cars may have one front and back. Obviously, if both sides of the suspension are connected together, we no longer have an independent system. A stiff bar reduces body roll, but too stiff can limit the operation of the independent suspension and cause the inside tyre to lift. Often a compromise is required.